Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 9th, 2025, just yesterday. This paper introduces a method for generating tests that improves what's called verifier accuracy by over 10% compared to the popular LiveCodeBench benchmark. The paper is titled, Rethinking Verification for LLM Code Generation, from Generation to Testing. And as we'll see, this has big implications for how we measure the real capabilities of these models. It argues that current code benchmarks have major blind spots and proposes a new human and LLM collaborative framework to fix them. So to illustrate this problem with current benchmarks, the researchers showed two key plots. First, a chart shows that verifiers, which are basically automated test suites built to catch LLM bugs, fail to find over 80% of human-written bugs. Then, a scatter plot from a principal component analysis, which is a statistical method to visualize data patterns, shows why. LLM-made errors are tightly clustered together, indicating they are very similar and predictable. In contrast, human errors are scattered widely, showing much more diversity. This really highlights the blind spot in current testing methods. To tackle this blind spot, the authors lay out different approaches to what's called test case generation, which is just the process of creating these tests. The diagram shows three ways of doing this. First, there's direct generation, where an LLM writes tests directly from the problem description. Then, input-based generation, where the LLM creates inputs that are checked against a known correct solution. Finally, their own method, which adds a key ingredient, human priors. This means guiding the LLM with insights from both correct and incorrect code written by people, making the tests much smarter. Alright, so this figure gives us a great overview of their proposed framework, which they call SAGA. That's short for Strategic Adversarial and Constraint Differential Generative Workflow. It's a really clever process. The LLM doesn't just look at the problem description. It also analyzes what they call ground truth, which is correct human code, and human bugs, which are incorrect submissions. By studying both what works and what fails, the model generates Python scripts for tests, along with explanations and validation code. This whole package creates much more challenging and diverse tests than other methods. Building on that idea of using human code, this table shows the initial results of that strategy on the @coder dataset. It compares the two basic test case generation methods we talked about, direct generation and input interpreter, both with and without adding simple human insights. The metric here is accuracy at 50, which is just the verifier's accuracy using 50 tests. And what we see is that for both methods, adding those simple human priors provides a noticeable boost, jumping by almost 4 to 5%. This is the first piece of evidence showing their core idea really works. Okay, and this table really drives that point home, showing the main experimental results on the TCGBench dataset. It compares their SAGA method against other baselines using a few key metrics. We see detection rate, which is how many bugs are caught, and verifier accuracy, which we've discussed, but also area under the curve, a measure of overall efficiency, and diversity ratio, which checks how varied the tests are. Across the board, SAGA is the clear winner, almost doubling the verifier accuracy of its closest competitor. It's just a much more powerful and efficient way to generate tests. So, if SAGA creates much tougher tests, what does that mean for how we actually rank different LLMs? Well, this figure shows the dramatic impact. It compares several top models on an old benchmark, LiveCodeBench, versus the new one built with SAGA called CodeCompass. The metric is pass at 1, which is just the percent of problems a model solves on its first try. Every single model's score drops significantly on CodeCompass, some by over 16%. This isn't just a harder test. It actually re-ranks the models, showing the old benchmark was giving a flawed picture. So to wrap things up, this research really highlights a critical flaw in how we've been measuring progress for code-generating LLMs. The key takeaway is that simple tests can create an illusion of competence. By developing the SAGA framework, which learns from both human successes and mistakes, the authors have built a much more rigorous evaluation standard. This not only gives us a truer picture of model capabilities, but also improves training methods like reinforcement learning with verifiable rewards, where models learn by passing these much tougher, more realistic tests. Thanks for tuning in. I'm Alex, and this has been the AI Research Roundup.